Okay. They're all fixed up. Just a few tests I want to do, of course. Measure some power output, distortion kind of things. Not so much measure distortion as listen for it and look for it. At some point I will indeed plug this into a speaker and put some music through it, among other things. I'm a little curious about the tone stack in this. It's somewhat elaborate. It almost assuredly is a boost and cut configuration. They go to the trouble to have these extra taps on the volume pot, pardon me, loudness control. They went to that trouble. There's a reason for it. So we'll explore that a little bit. Shoot, I just realized I forgot my calculator. I'll have to go get that. So we will do that later. For now, I've got the scope warmed up, frequency signal generator and counter are on. The scope's connected across the output of this. It's an 8 ohm output. Of course, the load resistor, 8 ohm load resistor for it. No speakers connected yet. Scope's connected across this resistor, as is my meter here, which will set to read AC volts. And down into the single-digit millivolts. All right. Scopes. Scopes weak out. Okay, so got the solid-state rectifier in here. It's been off for, no power's been applied for over a 24-hour period, longer than that. All the tubes are in except for the tube rectifier, of course, again, replaced for now with this solid-state one. Pardon me. Variacs here, set to maximum, which here is going to be about 125 volts going into this power transformer. It's turned off right now, but the dial is all the way up. Simply means that when I throw this toggle switch, line voltage, 125 volts directly in. I've already reformed the cap. If you looked at any previous videos, it's not having any troubles at all, near as I can tell. I'm interested. I put a 1 amp fuse, a slow blow, a time delay fuse, in line inside under the chassis, safety measure. Interested to know that under the worst inrush conditions, is it going to blow that fuse? If it doesn't blow that fuse under these conditions, in other words, fully discharged capacitor and a solid-state rectifier which does not slowly come up like these tubes do, in other words, it's on. And if that doesn't blow the fuse, after a couple of tries, this will just be the first one, I'm going to be satisfied that with the proper rectifier in there, the tube, it'll not be a problem. I don't expect it will be. So let's go for it, man. Turn it on. Yep, didn't blow the fuse. And just letting the tubes warm up a little bit. Yes, I'm interested in a couple of things before we apply signal. I've got the tone controls, the bass treble controls set midpoint. Volume controls all the way down right now. I do have the generator connected. And let's see, where are we at signal wise here? Well, put them about midway. That gives me, something like maybe 10 volts peak to peak. I could look at it, it's not important. What I'm really interested, I guess, is get it high enough to get a stable reading up here on the counter. Let's call it 1.6 kilohertz. 1600 hertz. Should be, a little bit of warmth showing on these output tubes. They seem fairly well balanced, and I'm not talking about heat-wise, but just some other measurements I did earlier. I don't expect there to be any trouble with that. Very quiet right now. Well, of course, with an 8 ohm load, I'm seeing 7.8 millivolts. That's nothing. Where I got the scope right now set 5 volts per division, so you're not going to see that. Let's see what it looks like. Get down a bit. Some of that noise is my crappy probe connection here. Another thing that I have to look at. So, I don't know if I can trigger on that. Just barely. Hey, that's so low in amplitude. That's a tenth of a volt per division. Coming out of the speaker output into its proper load, and the tube amp, that is remarkably quiet. We'll go back up to 5 volts per division. And let's add in some signal. Let me see if I can get that to trigger. There we go. Okay. So, crank them up. See how far we go. Wow, surprising. Need to take this. Oops. Wrong way, dude. Yeah, we'll go off cal. Not really interested in calibration on that. A little bit. Well, the pot's a little crummy. There we are. Yeah, it's not difficult at all to see where at what output point the distortion's happening, and it's, well, to that point at least, very symmetrical. I don't know what that's about. Don't care. A nice, clean sine wave right about there. And we're looking at 13.1 volts. Oh, I have to get my calculator because I want to know. That's more than 10 watts. Yeah. Now, you can see here it's reaching the power supply's limit. Now, bear in mind, this is a solid state rectifier. It's the highest output this amplifier is ever going to see again, if I have anything to say about it. Operating off of the vacuum tube rectifier, the power supply voltage is going to be lower, and this thing will just be sort of loafing along. It's going to run, a little hot. These are, toasty. You can see I can handle them. I'm not going to stick on the sides. But it's not overheating those. Certainly not these. Those don't care. Yeah, these are stone cold and will remain so. Load resistor here's catching a little heat. Nothing to worry about. It's like 14 volts with all that distortion. You can see it, the flat tops and the bottoms, and the crossover distortion, you know, where it crosses through zero. Does not surprise me. I'm going to take it back to less distorted. Okay, that looks pretty clean to me. Actually, let's get a nice even number, 13. Call it 13. Oh, I'll be right back. Okay, I thought that was high. It is. Right now, this amp is putting out a tiny bit over 21 watts continuous. 1.5 for, I'll call it 1.6 kilohertz. Putting out 21 watts. It won't do that with this vacuum tube rectifier in it. I'll guarantee it. And it's not... I wouldn't normally run an amplifier like this with a solid state, but there are exceptions. There could be a use. I'd have to look at some other things, you know, what it really is the plate dissipation on these. I don't want to wreck those. And what's the B plus voltage? Is it stressing out this capacitor? So I'm not going to do much more with this in here right now because of those unknowns. Driving these higher, the specs on these, I think the maximum for a pair of these, they spec something like 15 watts. But clearly they'll do more than that. Not sure I would sustain operation like that, but you know, if you're using it for a guitar where this, I mean, that was continuous signal. You know, from a music instrument, you're not going to normally see that unless you're driving the thing so hard it's in the distortion, and you know, I wouldn't worry too much about it. So for now, actually, I think I'm going to leave those hot and just swap out this rectifier. Being careful, of course. Don't like surprises. There you go. Nice tight socket, that. Plenty of room to fit. Okay, put him in. Give him a moment to come up. Kind of toasty. It's a, I don't know, maybe my calibrated fingertips, it's probably about 50 C. Pretty hot. Okay, so with the tube in there, volume's all the way down. Yeah, still church mouse quiet, 5.2 millivolts. I don't know if you can see the range displayed over yonder. This, by the way, is true RMS reading, and I find they're spot on from just a few hertz to 20 kilohertz. After that, not so much. But around audio frequencies, they're spot on amplitude-wise. Okay, so he's all lit up, I think. Let's see where we go. How much? All right. There's a completely foobar. Too much. Backing off where I don't see any clipping. It's interesting. It clips very evenly from top to bottom. It's good matching of the outputs. That looks about right. Okay, 9.97. We're going to call that 10 squared 100. Let me get it right. 100 divided by 8 ohms. 12.5. That's more like 12.5 watts. RMS continuous, 1.6 kilohertz into 8 ohms. And this could go a long time under these conditions. And the difference is, I mean, from 12.5 watts to 21 watts or whatever it was, it's just what rectifier was in here. Now these tubes are in very good condition based upon what I'm seeing here. I mean, very well matched. As I mentioned in the previous vid, they're both date coded exactly the same, so that makes sense. I think they're all original. Okay, so what else? Working with it as is. I'm curious about the tone controls. They truly boost and cut. We can get at that. They're set at midpoint right now, both of them. Bass treble, these volumes here. So I'm going to back off the power just a skosh. Don't want to be burning up for this. And we'll get a little bit more sensitive on the scope. This needs service. Let's do this. Boy. Pots. And probes. That range is a little too flaky. Don't need to worry about that right now. Really only care about amplitude. We go down. Well, it's, I guess, workable for now. Where are we at? So 200, or about 200 hertz. 200 hertz. So what does the, let's see, what was it? Look at this. Gimme. This is the controls. Okay, so this is bass, treble, and volume. So what does treble control do to that? Well, other than a little bit maybe noisy pot, I have not cleaned the pots. Doesn't have a whole lot of effect on that amplitude. Keep in mind, this is about 200 something hertz. The bass control. Back this off a little, see better. The bass control right now is centered. Go to increase. It does boost. Centered here, about center, and cut. So it truly is, at least on this control, boost and cut. Center is, call it neutral, flat. I like it that way. And the area about center is kind of wide. I also like that. Huh. Very good. And the treble control is having almost zero effect on the amplitude of that noisy pot in here. We'll see about that once we actually poke some music through it into a speaker. Alright, so let's go back up frequency a little. Yeah, that'll do. Give it a little more. Give it a little more amplitude. A few watts. And let's see. We'll crank this up. I won't quite go that high. Let's call it 15 kilohertz. 15 kilohertz. Thereabouts. Yeah. More amplitude. It distorts differently at that frequency, but only interested in amplitude. Now, let's see, bass control. All the way up, all the way down. Appears to have zero effect on that 15 kilohertz. The treble control, centered right now. We turn right, definitely boost. Turn left, definitely cut. How sweet of them to get it right. Let's look at the distortion a little bit more. I'm going to overload it at 15 kilohertz. And what starts to happen is the supply collapses. It turns into trash. But let's see, what are we getting at? Is it 15 kilohertz with what appears to be a fairly undistorted sine wave? You get 7.8 volts out of it. It's not bad at all. Let's see. Let me look at that. Wait a minute. It can't be right. Am I reading this? Yeah, 7.8. It's almost 8 watts. Oh, I should have known that. Yeah, sure. Yeah. A little over 7.5 watts, 7.6 watts. At 15 kilohertz through this iron. So that's a quality transformer, no doubt about it. I mean, you can usually spot them because the interleaving that they do in these laminations, how they stack those. So, let's see what we got here. They're pretty hot. Not out of line. The basses are fine. This guy, I expect him to be cooking. Yeah, that's pretty hot. These are just tiny little bit of warm, just barely perceptible. I mean, compared to this, it's cold. Output transformer, it's cold. So yeah, this is a lot more output transformer than really this thing needs with this kind of output. Surprised at that goes as high as it does with 15 kilohertz. Let's see what. Okay, it starts to really noticeably roll off. Let's call it there. That's 30 kilohertz. And what's this? Think about that. Overdriving it. Okay. Undistorted. Well, reasonably undistorted sine wave. 30 kilohertz through this amp, coming out into this load. 6 volts, 6. So even there's 5 or 6 watts. And, wow, not bad. That's the transformer I'm impressed with. Obviously these tubes, they'll go DC to daylight almost. They have no trouble amplifying RF at all. But getting that pumped through this transformer is a little interesting that it gets that much through it. Yeah, without a lot of complaint, really. Pardon me. So, alright, let's go down to the opposite end. Take her down. What do we got here? Way down. Way down. Probably gonna have to I might have to adjust here. I got it in autoing. Doesn't always work very well with low frequency. That's really a low one. Yeah, the amplifier's doing it. Clean that up a little bit. That's ludicrously slow. Let's get something we can read here. Let's see, we'll go. It seems to roll off quite a bit there. Let's see, period is 10 milliseconds per division. That's pretty low. That's sub-audible, really. And the amps, it's pushing it through. Let's see. It's hard to tell with it. Distortion seems to be occurring right about there. And we've got 6 volts into the 8 ohms. So it's doing it. Doesn't like it much, especially really give it some input. Almost looks like a heartbeat. Yeah, what have we got here? Put this back into autoing. Yeah, 120 hertz. And it's, oh, again with looking at the response of these controls. Bass control up, centered, down, so boost and cut. Treble control, doesn't matter where you put it, it ignores that frequency. Very good. And it might be fun to put a sweep on it, display it that way, but running out of time, and my resistors are they're not bad. I don't have to pump just a few watts through. Okay, so I think for now, at least, we're done with this. I got some cleanup to do. Got to put a strain relief grommet or whatever for the line cord. Actually shrink wrap around the fuse I put in there. And tag it, and for a while, and then use it. Actually, I might do another vid after this one. Yeah. Hook it up to a cabinet, or maybe this lab technique speaker I've been playing with here, and put some notes through it. See how it does. I already know how it does. These do well with that, so maybe play with that a little bit. But for this one, see it.